US Physics Olympiad, year 2020, F equal MA. First round, exam B. As usual, it was given 75 minutes for 25 problems. Problem number 1. A ball is bouncing vertically between the floor and the ceiling, which are both horizontal and separated by 4 meters. All collisions are perfectly elastic, and when the ball hits the floor, it has a speed of 12 meters per second. How long does a complete up-down cycle take? Solution for problem number 1. First, let's write kinematic equation for ball motion. We have height h equal 4 meters equal initial speed v, which is 12 meters per second, multiplied by time to travel to the ceiling, minus 1/2 gt square. So we need to solve this quadratic equation to time t. That will be 5t square minus 12t plus 4 equals 0. We have two roots. One root with a negative sign here is our solution, because in that case ball is going up till the ceiling, and the positive sign here is responsible for motion of this ball up to ceiling, up to highest point, and down to ceiling, which is not our case. So that will be exactly 1/2 of total time, because due to symmetry it takes the same time to go from ceiling to the floor. So finally we have total time equal 2t or 0.8 seconds, which is answer D, and that was solution for problem number 1. Problem number 2. A uniform rod of mass m and the length L has moment of inertia ml square over 12 about an axis that is perpendicular to the rod and passes through its center. What is the moment of inertia of a uniform square plate with mass m and the side length L about the axis along its diagonal? Solution for problem number 2. Let's place the origin at the center of mass of the square. The perpendicular axis theorem states that for a two-dimensional mass distribution in the xy plane, we have Iz equal Ix plus Iy. If the x and y axes are oriented parallel to the square's sides, then the moments of inertia Ix and Iy are both those of the uniform rod of mass m and length L. So we have Ix equal Iy equal ml square over 12. This implies Iz equal ml square over 6. Now consider rotating this axis by 45 degrees about the z-axis, giving axis x prime and y prime along the diagonals of the square. The perpendicular axis theorem now gives us Ix prime equal Iy prime equal ml square over 12, where Ix prime is the desired answer. By symmetry, we have Ix prime equal Iy prime equal ml square over 12. So that's the answer A, and that was solution for problem number 2. Problem number 3. A conical pendulum of length d swings in a horizontal circle of radius small r as shown. If omega is the angular frequency of this motion, what is omega square? Solution for problem number 3. Let's write equation for this motion in vertical and horizontal direction. Suppose that tension in this pendulum is T. In vertical direction we have equation t multiplied by cosine theta equal mg, where angle theta is angle between pendulum and the vertical. In horizontal direction we have tension multiplied by sine theta equal centripetal acceleration due to rotational motion, which is mr omega square. Now let's divide the second equation by first equation. We have omega square equal g tangent theta over r. But tangent theta equal r over square root from d square minus r square, which give us omega square equal g over square root from d square minus r square, which is answer D, and that was solution for problem number 3.